Hi everyone. In this session, we are going to discuss about atmospheric pressure. Like liquid, gases also exert pressure. We know that nearly up to 200 kilometers, our Earth is surrounded with air. You might have studied in geography, the different layers of air, right? Or atmosphere, right? If we consider the air as a column from that 300 kilometers till the Earth's surface, and if that weight acting on the Earth like a thrust, it possesses pressure. Okay, so we used to call the thrust acting per unit area by the air column on the Earth's surface as atmospheric pressure. If we consider the value of thrust or weight of this 200 kilometers air in this 1 meter square area, it is nearly equal to 10 to the power 5 Newton, or 10 to the power 5 means what? 1 lakh Newton thrust exert on 1 meter square area. If we consider it as a column of 1 meter square, 1 lakh Newton force or thrust exert on the area. Okay. Now, if we consider our body, if you see the area of our body, it nearly comes 2 meter square, right? That means we are also exerting nearly 2 into 10 to the power 5 Newton always. The earth is acting, or the air is always applying a pressure of 2 into 10 to the power 5 or 2 lakh Newton thrust on us. But we never feel that something is applying force on us, right? No. The reason is that we have blood pressure. So if we see the blood pressure, our blood pressure is little bit higher than this atmospheric pressure. So it will equalize, and in effect, we never feel that the atmosphere is exerting pressure on us. The existence of atmospheric pressure can be proved through some activity. Let's see the activity. This activity is for the proof of existence of atmospheric pressure. For that, I have taken a small cardboard and a glass of water filled till the rim. I am going to keep this cardboard upon this one. We'll see what happens. I'm going to keep this as upside down. Okay. Start. The liquid pressure is acting downward direction, but at the same time air exert pressure from downward direction. That's why this cardboard got stuck and the water is not flowing down. So comparing with the liquid pressure, atmospheric pressure is much more in this case. So this is a proof of the existence of atmospheric pressure. One more method is there for the proof: collapsing tin can. Okay. For that, you have to take a tin with an airtight stopper. Then take some water inside the tin and remove the stopper. Boil the water. After boiling, what will happen? The steam will be filled inside the tin. Right? No? So, you just close the tin with the stopper very tightly. Then, suddenly, you have to pour cold water upon the tin from the outside. So, the tin will collapse very fastly. Okay. The reason is that the air is applying pressure. Inside that, comparing with the air, the steam has less pressure. Okay. So, when you pour water, condensation is happening there. On cooling, what happened to the steam? Steam will condense to water. Okay. So, the air exert pressure from outside. Because of that, that tin will collapse very faster. Atmospheric pressure is more comparing with the liquid pressure in this case. If you see the standard value of atmospheric pressure, we used to consider the air pressure or the atmospheric pressure till the sea level. Okay, till the sea level. So we used to mention in terms of mercury column. So 1 atmospheric pressure is equal to 76 centimeter of Hg or 760 millimeter of mercury. Or we studied the value as it's equal to 1 atmospheric pressure is equal to 1.013 into 10 to the power 5 Pascal. So this is 1 atmospheric pressure at the sea level. See some examples related with the atmospheric pressure in our day-to-day life. Okay. When you go to bakeries or restaurant, we used to have juices, right? No? And when they give juice, they will provide one straw, right? How it is very easy to drink the juice through the straw. There also the atmospheric pressure exists, or it helps us to drink the juice very fastly. Okay, just consider like this is a juice and this is a straw. Okay, first what we will do, we will suck out the air which is present inside the straw to our lungs. So the air pressure inside the straw will be reduced. By that time, the atmospheric pressure exert on the juice and it will make the juice to rush into the straw. So in this way, it will help to drink the juice very fastly. Okay, you will be using the fountain pens, right? You have to press it, right? When you want to get the ink inside the fountain pen, you have to press that bulb, right? When you press the bulb of that fountain pen, you are evacuating the air which is present inside the bulb. So by that time, same way, the ink, the air exerts pressure. So it will be easy to rush into the fountain pen. And when you blow the balloon, it bulges. That's also due to the atmospheric pressure. Then we used to get water from the well to the water pump. Okay. So when we switch on the pump, what happens? First, the pump will suck out the air inside that. And so by that time, it will be easy for the pump to rush the water inside because of this atmospheric pressure. Then you might have seen the syringe. We used to fill the syringe with medicine, right? No? That when we pull back the plunger, we are creating a less pressure area. By that time, the atmospheric pressure acting on the medicine and it will rush into the syringe. We always use a rubber sucker as a hook. What you are doing when you get the rubber sucker, you will press on the wall. So when you press on the wall, you are evacuating the air from there. What happens afterwards? The air exerts pressure from this side, so it will make it to suck on the wall. You might have seen that the lizard, very easily it will be moving everywhere on the wall, right? No? So lizard's legs also act like a rubber sucker. It presses, by that time the atmospheric pressure exerts over it, so it can easily move on the walls. And if we get an oil can, sealed oil can, simply by one opening, the oil will not come out. You might have seen that your parents or your mummy might have done one more hole. So we have to apply or we have to put one more hole. So through that hole, the atmosphere will exert pressure on the oil. So easily we will get the oil out. In siphon system, we will be having two set of liquid. Okay, just consider we have two cans like this way. Okay, on the top one we have water. We have to get this water A to B. It is at a particular height. When the water is at a height, which kind of energy it possesses? It possesses potential energy. Okay, through the help of a rubber tube or a glass tube, we have to get the water from A to B. This system is known as siphon system. Here also we are using the application of atmospheric pressure. Okay, so we have a tube like this way. Then initially we know that inside the tube there will be air. First we have to suck out this air. We have to keep this end inside the water. Then take the tube, the other end of the tube, and suck out the air content from the tube. So atmosphere will exert pressure through this way. So this water will rush into the tube and it will reach the B. Okay. My grandparents, they were using this system. I don't know whether the people were knowing the science behind this one. They were living in the hilly areas. So there is no option to dig the well or anything. So through the stream, they used to get the water. Okay. So above the stream, if the house is here, from a higher position, there will be a small, like a, we know that in the stream also, we will get a right position to keep the pipe. So they were using the hose. They used to keep the hose there, and later the grandpa will come down and he used to take out the air through the hose. So slowly within few seconds, the water will reach the home. So it will still continue when we go there and lift up this position. Until that time, continuously we will get the water. So unknowingly, when our parents or grandparents are using so much of physics in our day-to-day life. Those who are going for trekking or the mountaineers, they used to get the nose bleeding always. The reason is that when they go to high altitude, the atmospheric pressure is getting reduced. So our pressure will be more than the atmospheric pressure. So always we know that from high pressure area to low pressure area, the liquid has a tendency to fluid. So by that time, our veins will break and nose start bleeding. So these are some of the examples in our day-to-day life related with the air pressure. Thank you.